Welcome to the channel. If you're new here, I'm glad you found your way. This is a place where we explore science not just as a collection of facts, but as a way of thinking about the universe. Physicists spend their lives trying to understand reality, but the way they actually approach problems is often very different from how science is portrayed in textbooks or documentaries. Instead of chasing final answers, they work with models, constraints, approximations, and patterns that slowly reveal how nature behaves. In this video, we're going to explore how physicists actually think, how they simplify complicated problems, how they build models that work even when the full truth remains unknown, and how curiosity and careful reasoning guide the process of discovery. How physicists actually think. When most people imagine physics, they picture equations that perfectly describe the universe. But in practice, physicists rarely start with perfect equations. They begin with questions. What is happening in this system? What can we measure? What assumptions are safe to make? The goal is not to capture the entire universe at once, but to isolate the parts that matter most. One of the first things physicists do is simplify. Real systems are incredibly complicated, so they start by stripping away details that don't significantly affect the outcome. A planet may be treated as a point mass. A gas may be treated as billions of identical particles. These simplifications are not mistakes. They are deliberate choices that make problems solvable while preserving the essential behavior of the system. Physicists also rely heavily on models. A model is not the same thing as reality. It is a structured description of how something behaves. The power of a model lies in its ability to make predictions. If the predictions match observation, the model becomes useful, even if it is incomplete. Many of the most successful theories in physics are known to be approximations, yet they remain incredibly accurate within the domains where they apply. Another key part of physics thinking is the search for constraints. Instead of asking what forces make something happen, physicists often ask what prevents other possibilities from happening. Conservation laws, symmetries, and stability conditions act like boundaries that shape how the universe behaves. Within those limits, patterns emerge that can be studied, tested, and refined. Perhaps the most important habit physicists develop is comfort with uncertainty. Science advances not by claiming final knowledge, but by gradually improving the models that describe reality. Each new discovery reveals deeper layers that were previously invisible. The process is less like solving a puzzle once and for all, and more like mapping a landscape that continues to expand the farther we explore. In that sense, physics is not just about equations or experiments. It is about learning how to think carefully about the world, asking better questions, building models that work, and recognizing the limits of what we currently understand. Thanks for sticking around if you've made it this far. My name is Charles Carroll, and this channel is all about exploring the universe through curiosity, persistence, and careful thinking. If you like these kinds of videos, consider subscribing, liking the video, or even sharing it with someone who enjoys science. And until next time, join me again. Who knows where the science might lead us?